Hi, and welcome to Mike's Garage. So today we're going to look at the Solis 11.4K high voltage inverter along with a pair of these LG 16 kilowatt floor standing batteries that are set up. As you might recall, this is a test setup. I'm going to be moving the equipment, but I wanted to show you what it looks like all hooked up, some of the capabilities, and then I'll show you the app as well. So with this is a hybrid inverter, so you can set it up to where it's off-grid or on-grid, totally up to you. For me, I set up an off-grid. I prefer being off-grid. I personally don't want to sell back to the grid or potentially just kind of save money on it. I'd rather be disconnected from the grid. So this is an off-grid setup for me, and that's what I'm going to show you today. And then the batteries, these are the LG 16 kilowatt batteries. These are floor standing and they are lithium ion Gen 3 technology. Now both the inverter and the batteries are set up to be both indoor and outdoor. But please note, if these are set up outdoor, you're going to want to make sure that you have some sort of an overhang so they're not directly have rain on them. And also, you'll want to make sure that it's kind of protected from the sun, so you don't want it in direct sunlight. But they are moisture proof. They have all the certifications for that, so feel free to put these outside, and I'll probably move the batteries outside at some point just to kind of save a little bit of floor space. Anyway, so these batteries, once again, are 16 kilowatts each. They are made by LG. They pack quite a punch. Now, I'm not going to do a demo on the inverter today and the batteries. I am charging them, and I'm at around 22%. So I don't want to do a full test right now, but I will in the next video. What I will say is I have done some testing with it, and it has tested out quite well. So we're going to kind of take a look at everything. We're going to look at the app, and I'm going to give you the pros and cons of the system compared to my existing off-grid system. All right, so these batteries, you open them up. They do have communication in them, so I do have a Cat 6 cable connecting the two batteries together and then also to the inverter. So there's actually 4 wires that connect to each for communication, and I'll show you that just in a little bit when I take this cover off. We'll kind of go through each one of them. Wiring and setting this up, I would highly recommend watching Kelly's video from Signature Solar on how to do the deployment. Kelly did a phenomenal job walking you through from beginning to end, and that helped me out tremendously. So inside, when you open these up, you have a large breaker on this right corner, and then you have your LEDs on the left. Behind this cover are the actual electrical connections. So with the batteries, you're going to use 8-gauge wire that is rated for the voltage. So the batteries can go all the way up to 450 volts. So make sure that you're using cable that was capable of 600 volts. All right, so with the cover off on the inside, you're going to see that I have 2 cables right here. So I have a total of 3 solar panels that are 40 volts each in series to give me approximately 120 volts. On the solar controller built into this, the MPPT controller, it can take a range of, I believe, all the way down to 80 volts and all the way up to, I believe, 500 is the range, but it may go up to 6. But check out the specs, will have that in there. But what I like is that the minimum is 80, so you can put 3 panels in series, get your 120 volts, and you're good there. So with installing the batteries, it is 6-gauge wire that it could handle. I believe the batteries are 8-gauge, so you're going to take the 2 8-gauge wire, you're going to connect them together, and then from there you're going to have it go into the battery input. Here is where your load is connected. So what's interesting is kind of how they label these things. So if you look at this, it says backup. Backup is your panel. And then to the right, grid is your actual grid. Now the naming convention on a lot of these things is a little different, so you got to get used to it. But with this, you've got your L1, L2, you have your neutral, and then you have your ground. Now with these inverters, they are not bonded from the factory for your neutral and ground, which they should be bonded on your service panel. So just kind of note these are unbonded, which is good because otherwise you'd have to either disable it in the app. There are 4 wires that are in here that are kind of hidden. You have to make the cables together using Cat 6 cables, but you have your 485A and then B, and then you're going to have your enable and enable ground. So the 4 wires, once again, Kelly's video kind of spells it out really good, how that you wire that up. But you do have those connections, and that's the communication between the batteries and your inverter. On the right-hand side, you're going to have your emergency disconnect button that you can press. You could also install a separate one that you would mount somewhere else. And then you also have your inverter control. Is it in bypass mode? Is it, sending out to your panel? So it does have that inverter bypass there. And then once again, your dongle, and then I believe that's your Bluetooth. So as far as the connections on it, it is pretty simple. It does have a handy diagram. The MPPT controller does have 4 strings, which is nice. And then for the manual, scan that and you can then download it. As far as on the screen itself, it will typically show your battery level, and then it will also have Wi-Fi, and then the state of what the inverter is in, which it shows blue right here, which is normal, and the batteries show green. Couple things that you want to do when you're configuring this and setting this up. When you sign up for the app, there is a owner and there is an installer configuration as far as which account to set up. Always do the installer, because the installer is going to have more options for configurations, whereas the owner is going to have a lot less. So if you're an installer, you're setting this up for an owner, you want them to be able to see the state of everything, but you don't want them monkeying around with it. That's going to be the owner. You're going to want to do the installer one. It doesn't cost anything to set up these or anything like that, but definitely do the installer. And I believe that there's also installer videos as far as how-tos on their website. So that's pretty much it. Each of these batteries can put out continuous 7,000 watts. I think it's around 11,000 peak, but 7,000 each. So between the 2 of those, they can supply more power than what this inverter can use. If you're looking at setting up something like this, go with the 2 batteries instead of the 1, because if you go with 1, your maximum continuous is around 7,000 and you'll never be able to max out the inverter. So I'm going to put this cover back on. Okay, so I'm in the app. I'm going to show you a few things in it. So for the inverter, you can see that with the solar panels that I have connected, the sun's pretty much set at this point. Very little power that's coming in, but you can see it coming into the batteries. The battery charge for the pair is 22%. So once again, that's why I'm not doing any sort of load test on it right now. It does show down here what the PV voltage is. So right now it's 110 volts, 0.4 amps. I'm only putting in 44 watts at this point. It does show your warranty status, which is good, and then the serial number on the unit as well. Going to the configuration on this top right, you're going to see something that says inverter control. You're going to click on that, and then you're going to accept, and then you're going to have to put in your account password. All right. So here's the configuration on the left. I'm going to go through what I understand, and the aspects that I don't understand, I'm just going to leave out. So there's 4 different modes that you can do: self-use mode, feed-in priority mode, peak shaving mode, and off-grid mode. So the standard mode that most people are probably going to use is a self-use mode, okay? And with that, I'm currently, using the off-grid mode. All right. So in the off-grid mode, you can, let me show you the configuration for that. The off-grid mode I have selected as enabled. I have my minimum battery SOC before the inverter turns off. Before the inverter turns off is at 10% for the batteries. You have your battery settings. So I'm going to bring this up. So the battery is a LG 16H. LG parallel is on, so it knows that there's two batteries. Max charging 50 amps, max discharging 50 amps. Over discharge, once again, it says when the battery is reached over discharge, inverter will stop discharging the battery. So essentially it will disconnect and no longer supply power. So I have that at 10%. Over discharge, Hysterius SOC. Spoke to Solis about that. It's for some reason, if it does go below 10%, this will then kind of like a fail safe for the battery to protect it to disconnect. So you're going to want to have this lower than the over discharge number. Force charge, so if you were connected to the grid, you can have it force charge at a certain percentage, so that kind of overrides some of the selections. Battery healing switch, what this basically does is it sets a cap on the amount that you can charge it. Now in the generator settings, you could actually set it there as well, but I have mine set at 85%. So that is the target that it stops charging the battery. And the reason why you want to do that is since this is a lithium ion battery, not a lithium iron phosphate, you really don't want to bring it up to 100% charge, because even though this is a Gen 3 battery, it will, still potentially shorten its life. Whereas lithium iron phosphate, it's not as much of a deal. Max charge, you can set this at, so it's at 100. I should probably lower this down to 85 as well. Peak shaving, I'm not using any of that. That would be a function for someone that has a grid connection. Grid code setting. So this is all of the settings that you would use. So hopefully you can see this on the left for selling back to the grid or sending power back to the grid. So you would select your code for that, power limits, a whole bunch of different settings. And to be honest, half of them I don't understand. My knowledge set is pretty much with off-grid. Backup settings. Backup settings, you're thinking is some sort of a backup. It's not. Remember, backup is what it calls the output that goes to your service panel. So I have backup port enabled. If it was disabled, the inverter wouldn't power anything. So I have that set as enabled. I have it set at 240 volts. If for some reason the inverter is under strain, voltage droop setting, from what I'm told, will allow the voltage to drop a little bit when an overload is in place. So let's just say you're pulling too much of a load. This will kind of lower the voltage a little bit. Now you can turn this off, totally up to you, but that's kind of what it does. Under more functions, you have AC coupling, gen settings. So if you had generator input, you can do a generator instead of AC coupling. And then you would set, like, here's your start charging and your stop charging, and how it would start the generator either by generator control or inverter on or off grid signals. It also has advanced settings down here. And a lot of this is for setting up. So you have your meter settings. Right now I have mine set up for no meter, but if you have your Acryl and you're connecting it up, and this would be for all of the other configurations. So if you're using this self-use mode, feed-in priority mode, peak shaving, all of those, you're going to have to connect your acrometer up and get all that wired up. For off-grid, you don't need it. So I love simple. So you can make some changes to how often the scanning is done for the MPPT controller. So I believe that if you increase the frequency of how often that it scans, it will lessen the effect of shadows on the panels, from what I'm told. And then it's got some special functions. It has parallel settings. So if you have two inverters, you have your parallel settings set up. Okay, so now final thoughts. So far, I've been pretty happy with it. I have done some basic tests on the batteries and on the inverter. They have tested out quite well. I'll have more details on it. You'll see that in the next video once I get a little bit more charge to it. So things that I like. The inverter does put out quite a bit of power. It does have these massive aluminum fins on the back, which do work extremely well. It doesn't have an external fan of any sort, so you're not going to hear the inverter at all. So obviously it's going to be quieter than like the EG4 12000 XP that I have, which really isn't that bad, but you know, it does make some noise from time to time. So this is very quiet. The software does work pretty well. I do notice that with the monitoring, it's a little bit slow as far as the updates. So you put something under load, you might have to wait a little bit for the next refresh. Other things that I do like about it, it is simple as far as the wiring. So you have your 4 communication wires, you're going to have your power wires to your batteries, and then you're going to have the acrometer, which is going to go into your main panel, and essentially it will let it know how much power that you're using and essentially how much energy it should feed either to the grid, or if it is trying to not charge but just reduce your bill, it will adjust that so you're not actually putting on the grid but still saving money and keeping the batteries topped off. So you'd have to wire up that as well, and that does come with the kit. With the batteries, extremely happy with them. For the tests that I've done, these pack quite a punch. These 2 batteries are almost equivalent to my lead time batteries all put together as far as output. This will handle 14,000 watts continuous, and it would do 22,000 watts peak. So this will definitely run this inverter and probably a second one with it. The communication on it, once again, is easy. The setup, as far as building it, okay, so I'm 140 pounds. I was able to put this together on my own. The batteries, each one of these halves of the battery are 150 pounds each. So they are heavy. They are a little bit hard to move. I was able to do it, but I was struggling, and my back belt definitely got some use. This top part is 50 pounds, so that was pretty reasonable. So once again, tests out extremely well. Very happy with it. Now the cons. A few cons that I want to go over. So I'm going to take off this cover again real quick. Couple things I want to show you. All right, so first recommendation. When it comes to the batteries, as far as the cable that comes in, the thickest gauge that you can do is 6 gauge, which is decent, but the batteries can do 50 amps peak. I believe 6 gauge, and correct me if I'm wrong, is maybe 55 amps. I would want to either have 2 connections on the motherboard, 1 for each battery, or put in bigger terminals so we can put in like 4 gauge wire. I always believe in increasing wire size where available so you're not that close to the limit. And then that way your wire is going to be cooler, makes it even safer, and is going to make the system more efficient. When it comes to the output wires that are going to go into your service panel, you have your 2 hots, you have your neutral, and you have your ground. Once again, This is 6-gauge wire for it. The inverter puts out 47 amps. It can peak a little bit above that if you have some sort of a surge. My concern is the wires, even though it tested and it lifted up a car perfectly fine, once again, increase it to 4-gauge. That would be my recommendation to ensure it could handle more current, or you can make it even bigger. And why do I say that? So on my 12,000 XPs, they have massive lugs on them. I'm able to use aluminum wire connecting my 12,000 XPs into this control panel. I'm using 1/aught wire connecting each one of these in here, and then 2/aught out of this combiner panel into my main service panel. I don't mind running aluminum wire at all. I know some people are kind of against it, but here's the thing. When you look at your meter base, a lot of times it is aluminum. You just got to make sure that it's sized properly. 4/aught is capable of running 200 amps for aluminum, and that's what the power company uses. So as long as you have your voltage drop under a certain amount, you're fine. For a house, I think it's 3%, but you know, if you could save some money, do that. Try to use thicker connections. For the copper, go from 6-gauge to 4-gauge. If you want to be really nice, go with even bigger so people can run aluminum. Going to the AC grid, this will handle 4-gauge, which is obviously nicer. I'm good with that because that can handle, I believe it's around 85 amps, but I'd have to look that up. When I was connecting these together, it is using 8-gauge wire coming out of the LGs. It's then combining up here, coming out a single 6, and then it's plugging into the inverter. Other things, I think I mentioned this before. This disconnect is for both solar and your batteries. There's not a separate disconnect for your solar and your batteries. So just kind of know that that's combined. So if you're hooking up, say, your solar cables and that switch is on, and you're thinking that, you know, oh, my solar connections, there's going to be nothing there. No, you're going to get bit. The screen gives you some information, but not much. It's hard to tell what it's doing, and the app doesn't tell you the current state. It will tell you if it's online as far as the dongle. It will tell you if it's in alarm status. It will tell you that it's off. But if you have this connected up and you don't see much on there, you can't really tell its state. You don't know what it's doing. It's kind of like a black box. If you've ever done pen testing of an application, you know the input going in, you know the output going out. You have no clue what's going on the inside. It's kind of similar to that. You've got to figure it out. I ended up having two calls with Signature Solar and 3 calls with Solis to get this figured out. Part of it was because of me, because I haven't wired up or configured, that is, a hybrid inverter. Kudos to Kelly from Signature Solar for doing an install video on this. I used that video. I had to have watched it 3 or 4 times, and it helped out tremendously. Otherwise, I would have been completely lost. So if you do end up getting this inverter or the batteries, definitely check that out. Not only should you go over installation, but she also goes over safety as well, which is definitely key. So that's it. Thanks again for watching Mike's Garage. Please like, subscribe, leave a comment.